will introduce you as we go along. Okay. So, are the schools open for you? सबके स्कूल खुल गए? क्या क्या पढ़ा है अभी तक? Reflection of light. अच्छा, बाकी किसका क्या चालू किया? टेंथ पे दे दिया, 9th भी होगा ना? अच्छा 10th बस अटेंडेंस 10th का है। So we will be going in order, okay? Like so, first topic first. So I'll be starting with the first chapter, which is measurements and experimentation. And those of you in the school, if a different topic is being taught, if you have any doubt, you can ask me. So I'll clear the doubt, okay? So that you are also at ease, right? But here we will be going in the chronological order. So first topic first. Now, as you know that physics is an experimental science, right? And in experiments, we need to measure physical quantities and express the measurement, right? So, physical quantity is something that can be measured. Let us define what is physical quantity. Right? So, in experiments, we basically end up measuring various physical quantities. So, what is physical quantity? It is a substance which can be measured. It is substance that can be measured. Substance, or it is anything that can be measured. That can be measured. Right? So universe consists of infinite number of quantities. So can you memorize all of them? It's not possible because there are so many quantities to deal with. So fortunately for us, we don't have to remember so many physical quantities. We have to remember only fundamental quantities. Okay? And it is observed that all other quantities are made out of those fundamental quantities. Those fundamental quantities are very few, less than 10. Okay? So that can be measured. First, let us write down what are. So physical quantities are of two types: fundamental quantities or base quantities, and derived quantities. Okay, what are these? These are types of physical quantities. Okay. So let us become familiar with what are the fundamental or base quantities. So I will write it over here. Then you have SI unit. then symbol of it. So like I said, we need to measure the physical quantities. To measure the physical quantity, we require unit. So we'll once again explain what is the meaning of unit little later. Right now, first, write down what are the fundamental quantities and what are their units. Okay. So most familiar physical quantities are length, mass, and time. That we come across on daily basis. Length, mass, time. Right? These are the most basic fundamental quantities. And we deal with it almost on a daily basis. Can you see other things in the room?
Yes, sir.
What else? Temperature? Okay, temperature. What else? Electric current?
Yes, sir.
Can you see the brightness of the light?
Yes, sir.
It is called luminous intensity. So the brightness of the light is also called luminous intensity. Then you have 7, which is amount of substance. Okay, so I'll discuss what is amount of substance. So these are the 7 quantities, 7 fundamental quantities. There are 2 additional quantities also, apart from this. Plane angle and the last one is solid angle. Okay. So SI stand for International System of Units in English. Okay. International System of Units. Whereas SI is the acronym for a French explanation. What is French? Système d'Internationally. Okay, that is the French extension of SI. So, but in English it is International System of Units. So, SI. The whole world today follows SI units. So, all the quantities we will be measuring in SI units only, unless some other system of units is mentioned. Right? So, apart from SI, you have CGS units, and we will see as we go forward. So, what is the unit of length in SI unit?
Meter.
Meter. Okay. So, it is meter. So, full form of the unit is written as in lowercase only, meter. Okay. And what is its symbol? M. Small m. SI unit of mass is kilogram. What? Newton. SI unit of mass is kilogram. All written in lowercase. And its symbol is kg. K small, G small. SI unit of time is second. And symbol is small s. Small s. What about temperature? Kelvin. What about its symbol? Capital K. Why capital K? Because it is a name of a scientist. So whenever the unit is named after a scientist, the symbol is taken as the capital of the first letter of the initial. Okay? Only when the unit is after a name, it is in capital letters. There are certain other exceptions, we'll see that. Now electric current, what is the unit of electric current? Ampere. Ampere. This is also a name of a scientist. So its symbol will be capital A. Unit of luminous intensity is candela. And its unit is, symbol is small c, small d, CD. You won't be using this unit in the entire course. But just for your knowledge, that luminous intensity is candela. Okay, so not in 9th. Then this is amount of substance. Its unit is mole. And symbol is just MOL. Now this we need to understand in detail. What is a mole? So any idea what is a mole? So whenever you are dealing with atomic substances, atom, these are very, very small entities, right? So what the mole concept says is, there is something called as mole concept. So mole is just a number, right? What is 1 mole? 1 mole is equal to 6.022 into 10 raised to 23. This is the number, just like dozen has 12 quantities. Okay, so 1 mole is equal to 6.022 into 10 raised to 23 numbers of atoms or molecules or compounds. Because at atomic level, we don't deal with one atom. Like if it is a car, we can say one car is moving. But one atom is so small that if you have to measure its mass, how do you measure atomic mass? AMU, right? So what is 1 AMU? Atom is measured in atomic mass units, or it is sometimes also written as 1 U. AMU or 1 U is same thing. In kg, it is roughly equal to 1.67 into minus 10 to the power minus 27 kg. This is a very small number. Huh? Does it make sense? It is almost zero, right? In physical, in real world, this amount of mass is almost negligible. But at atomic level, it is not negligible. Now, the mole concept, what it does is, it relates the atomic level, atomic world to the real world in which we live. Meaning, we are more familiar about kilogram as mass unit in the real world. We know what 1 kg feels like. Okay? And we also know that 1 kilogram is equal to almost 1000 gram. So we know that a gram is 1000 part of a kg. That also we know, right? So in atomic world, if we take these many numbers of atoms, then it weighs, what is the mole concept? 1 mole of any substance. Any substance means it could be atom, molecule, ठीक है, will weigh its atomic or molecular weight in gram. This is a concept. Okay. For example, if you take one hydrogen atom, so what is the mass of one hydrogen atom? Roughly this much. But if you take, so one hydrogen atom, what is the atomic weight of hydrogen? 1 U. But if you take 1 mole of hydrogen atom, means if you take these many hydrogen atoms, then it will weigh 1 gram. You understand? A bunch of so many hydrogen atom, 1 mole of hydrogen atom will weigh 1 gram. Now 1 gram is more relatable to us. So whenever we are dealing at an atomic level, we actually take some amount of substance, not just individual substance. Okay? Is that clear?
Yes.
Like a dozen. In real world, we have a dozen. 12 units of anything is called a dozen. So in atomic world, this is a mole, amount of substance. So whenever we attach mole with any substance, it means these many quantities of or units of that substance. Clear? So in physics, you are going. In chemistry, you are going to learn a lot about it. Okay. So this is the whole concept. All right. Now next is plane angle. So what is an angle? So plane angle is angle in 2 dimensions. Right? Plane angle is angle in 2 dimensions. So let us say, so this is a line, this is another line, right? So this is the angle in 2 dimensions. So 0, how do you measure angle? Degrees, right? You are familiar. So this is 90 degree, 180, 270 and 360, whole circle. Okay. So, but degrees is not the SI unit of angle. SI unit of angle is radian. What is it? Radian. Okay. So what is the example of plane angle? So suppose on a paper you have a circle. So circle is a 2D object. Is circle 2D or 3D? 2D. Because it is made on a paper, which is a 2-dimensional thing. So in a circle, when the radius of the circle rotates, then the angle increases, right? So 90, 180, so 90 plus 90, 180 plus 90, 270 plus 90, 360. Okay. So there is a relation between degree and radian. In a circle, right now is 0 degree, but when the radius turns by 90 degree, okay. So in terms of radian, we call it pi by 2. So 90 is pi by 2. Pi by 2 radian. Okay, so the symbol is RAD. This is the relation between degree and radian. So when it turns by another pi by 2, that is 2 pi by 2, so that becomes 180 degree. So 2 pi by 2 is nothing but pi. Pi by 2 plus pi by 2 is pi, right? So pi is 180 degree. So this is pi. Right? Then this angle is how much? This is 270 degree. And this will be pi by 2 plus pi by 2 plus pi by 2. So this is 3 pi by 2. So 270 degree is 3 pi by 2 radian. And this is 4 pi by 2, which is 2 pi. Okay, and this will be 360 degree. Or 2 pi. So pi by 2 added 4 times will become 2 pi. 4 pi by 2 is 2 pi. Right? So is the relation understood?
Yes, sir.
Huh? So how much is pi?
22.7.
So pi radian is equal to 180 degree. We just saw that. So what is 1 radian? 180 degree divided by pi. And pi is 22 by 7, which is roughly 3.14. So this will give you roughly 57.3 degrees. So 1 radian is equal to 57.3 degrees. Okay, this is the relation. So you are going to deal with the SI unit of the angle quite often in mathematics, and we will see briefly in this chapter also. Now let's come to solid angle, which is a 3-dimensional angle. About this you will learn in more detail in 12th standard. Okay, the unit of solid angle is steradian. And its symbol is SR. So till 7 are fundamental quantities, and then these 2 additional quantities are there. But together it completes the base quantities. Right? So we have just named the fundamental quantities, but what about them? All these quantities can be measured independently. They do not depend on any other object for their measurement. That's why they are fundamental. They can be measured independently or directly. Okay, so they don't depend upon other quantities. So these, they can be measured independently. Okay, this is how the fundamental quantities are defined. What about derived quantities? All other quantities in the universe are derived quantities, meaning are going to be combination of these quantities. We'll see with examples. Derived quantities, these quantities depend on other physical quantities, other fundamental quantities for their measurement. Okay. So I know the board has become a little busy, so the sequence you have to follow is first write down physical quantity, then types of quantities, then write this, and on the margin you can write this alongside plane angle, etc. Whole concept you can write alongside amount of substance. You can just see how you want to do it. Okay. So if you have any questions, you can ask. Okay, solid angle, 3D angle. Any idea what could be a 3D angle? Cube is a 3D object. So 3D angle. Huh? 90 degree form is cube. No. Cone. Cone is a like how? I mean, let's say this is a cube, okay? See the corner of the. So which angle is a solid angle? This 90 degree. This 90 degree. So if you take 90 degree, it is still angle between two lines. Okay. So what is a solid angle? It will be more clear if you take a sphere. It is possible to make solid angle in this also, but it is more easy to understand if you take a sphere. So consider a sphere. Okay. Say a football, right? So draw a circle on its surface, on the surface, right? Then draw a line to its center. So what is it? What shape is this? It is a cone. So the angle formed by the cone, this angle, is a solid angle. It is a three-dimensional angle. Okay. So inside cube also you can carve a cone. Then it is solid angle. So if you imagine there is a circle here and the base is going and hitting the corner, then that is the solid angle. Got it? But more about solid angle in 12th standard, not now. So in the meantime, if anybody has any question, you can ask.
I didn't understand the concept.
Mole concept. So mole concept actually relates the micro world to the macro world. In what world we are living? Macro, big, everything we can see and feel and measure it. Can we see atoms? Invisible. But we know today that atoms do exist. All our composition, everything is made up of atoms. That is the smallest entity of any substance. Correct? So if you want to understand any quantity better, we need to understand its behavior at atomic level. Because that only must have grown into its extended manifestation. Correct? So how to deal with atom now? Because the mass, etc. are so small that how do we correlate? We learn things by correlation, right? By comparing things. So how do we compare atom with what? We compare things with the known quantity. So in terms of mass, we know kilogram and gram. So if we take one atom, its mass is so less that it doesn't make sense. That's why whenever we are dealing at atomic level, we don't deal with just one atom. We take collection of atoms. Okay. So what collection now? So somebody suggested we should take these many. And this also has got a specific name called Avogadro's constant. So if you have collected these many atoms, a group of these many atoms is called 1 mole of atom. Okay? Now the beauty about this number is, if you take 1 mole of any substance, say hydrogen, oxygen, any. So whenever you take 1 mole of any substance, its mass becomes equal to its molecular weight in gram. Okay. Now, atom and its molecular weight is available to us. There is a periodic table available, okay, which gives the name of the atom and its molecular weight in atomic mass unit. Okay, but atomic mass unit say we are able to convert that into gram, which is more familiar. We are more familiar with gram and kilogram. So mole helps us do that. Okay, so the atomic weight is now converted into gram weight with the help of mole. So as you study more, okay, in chemistry and solve more numericals, you'll become more comfortable. Right now it's like A for apple, B for baby. We are at that stage, so far as mole is concerned. Then you'll be at a stage where you'll start forming words, sentences. Okay, then it will start making meaningful statements. Just like that, mole is at an alphabet familiarity level right now. So when you start using it, you'll make sense of it.
Sir, can you give an example using this mole concept?
Yes, I just now gave the example only.
Using it in
No, so for that you have to read chemistry, more thing. Right now, what I said is, this is the example. If you take these many group of any substance, say molecule or atom, like what is the molecular weight of H2O? Any idea?
one U.
1U. And what is the molecular weight of H? H is 1U. What is H2O? So 2 into 1 for hydrogen. Plus what is oxygen? 16. So 18U. It is 18U. But if you take 1 mole of H2O, okay? So 1 mole of H2O will not be 18U. 18 gram it will be. Okay? Gram is just G. If you take 6.022 into 10 raised to 20, it's a very large number of water molecule, water compound, then that will be 18 grams. Okay? That's what it is. Suppose I ask you a question. I gave you 18 gram of water or 18 kilogram of water. Now I am asking you a question. Tell me how many water molecules are there in that? I give you a glass of water, say 1 kg. Okay? And now I am asking you a question. Tell me how many water molecules are there in this?
Divided by 18.
Then you will have to use the mole concept. Because in 18 grams, how many numbers are there? 6.022 into 10 raised to 3. Okay? So 18 gram means 18 into 10 raised to minus 3 kg. So 1 kg will just do unitary method. This kind of questions will come. You'll be given amount in kg and you'll be asked, okay, find out how many molecules it consists. Then you have to use mole concept. So it relates the atomic world with the real world, physical world in which we live. Micro to macro. Clear? Little bit? So don't worry too much about it. It will be, there are a lot of details that you are going to study and it will be okay. Whatever we have studied today, is it clear now?
Yes, sir.
Okay. Let's go ahead. We have to come back to now unit because we are dealing with measurement. So how to express measurements? Okay. Any physical quantity is presented in the form of or in the combination of its value its numerical value which is also called magnitude and a unit. Okay. So measurement of any physical quantity is presented in the combination of its numerical value and unit. Example. Say 100 meter. It's a length measurement. So 100 meter. So 100 is the numerical value or magnitude. And unit is meter. Okay, so any measurement will have two components, magnitude and unit. So magnitude is the numerical value, right? Or if you have 50 kilogram or 60 seconds, this is how measurement is presented or expressed. So what does 100 meter means? When I say 100 meter, that means I have to know what is a meter. I have to know what is a meter. So this measured length is 100 times of certain standard length, which we call meter. Understood? So how a length is measured? It is measured by comparing a standard unit, a standard reference length. That standard reference is called unit. So I have to know first what length is 1 meter. Now who decides that? We always go to shop, so he has a metallic bar or a tape with markings. He says the length between 0 and 100 centimeter mark is 1 meter. Who decides that? Huh? Who decides that this is 1 meter? Can you call this length 1 meter? Huh? So the top scientists of all countries get together to decide the standards. It's not decided by one person. There is something called as Bureau of, I don't know, Bureau, what is this spelling? Bureau of Weights and Measurements. So there is a global Bureau of Weights and Measurements, right? Every country has that. Bureau spelling mistake. Yeah, it's a weird spelling.
UREA.
What is it? BU?
BUREAU.
So it is Bureau of Weights and Measurements. Every country has this body, government body, which maintains the measuring standards. Like in India, we have something called as National Physical Laboratory, NPL. National Physical Laboratory, okay, which keeps all these measurements. What is 1 meter? How much mass is 1 kilogram? Somebody has to decide, somebody has to fix it, right? Then only you can compare against it. Not only in our country, all the country also will have to agree for it. So from time to time to decide about the standard units. Okay, conferences keep happening at a global level, and there the decision is taken that what length is 1 meter, how much mass is kilogram. So, for example, there was one conference which happened in 70s or 80s, right? 1970s or 80s, at a place called Sevres near Paris. Okay, where they decided what length is 1 meter. So that time there was a platinum iridium rod, an alloy of platinum and iridium rod with some markings. Okay, so that rod was considered taken as 1 meter, and it was divided into 100 parts. Each part was then taken as a centimeter, and the centimeter was divided into 10 parts. Each part was millimeter, and then copies of that was made and issued to all the countries. So all countries maintained it at their Bureau of Weights and Measurement. They made multiple copies and then gave it to retail outlet for further selling. So one reference is multiplied into so many references. Understood? This is how it works. So standard has to be really standard. A meter in India should be a meter in UK or US or anywhere. Okay? Otherwise the purpose will be defeated. If the units are not same everywhere, and anybody will decide, okay, this is 1 meter or less. वैसा नहीं चलता है. So these are standard references. So now let us come to what is a unit. Can I erase that? Yes. So having understood how the measurement is expressed, so measurement is basically, it will only make sense when you know what the unit is. Okay? So what is unit? Unit is a standard reference. Standard reference. Which is compared with the physical quantity of same nature okay, for its measurement. For its measurement. Okay, so this is what is it. It is a standard reference which is compared with the physical quantity of same nature for its measurement. So imagine this is 1 meter. This is 1 meter. Now I want you to measure the breadth of the board or the height of the board. So what is the height of the board? Let us start this white portion only. So this is 1, 2, 3. I am comparing the length with a standard length. 4, 5, 6, nearly 7. Okay, so I compared length with the standard length. Okay, this is what. So unit is a standard reference which is compared with the physical quantity of same nature. This is some length. Now I am comparing length. Then I can present what is the measurement. So I have to know some standard reference. Is that clear?
Yes, sir.
So likewise, we have standard reference for all the fundamental quantities. Okay? Clear?
Yes, sir.
Now, let us have some examples of derived quantities. So we have learned about fundamental quantities. We should also know what are the derived quantities now. So let's begin with area. What is area? Length into breadth. So what will be the unit of area? Unit of area will be unit of length and unit of length. Meter into meter, which is meter square. So area depends on unit of length. So area is dependent on unit of length. So it is a derived quantity. It derives its unit from fundamental quantities. That's why it is derived quantity. Okay. Now let's look at volume. What is volume? All or length only. So volume also depends on unit of length, which is fundamental quantity. So this will be meter cube. Okay. Now let's come to speed. What is speed? Distance covered per unit time. Right? Speed is distance upon
Time.
time. Distance is length. Time is also a fundamental quantity. Both are fundamental quantities. So what is the unit? Meter per second or meter per second. So now speed is a derived quantity because it depends on unit of length and unit of time. So take any quantity other than the fundamental quantity, it will be derived quantity. And the units of derived quantities are called derived units because they are derived from fundamental quantities. Is that clear? So you will have now uncountable, so many derived quantities. Okay? But they will all depend on those 7 plus 7 units. Let's take some more. What is velocity? That's force. What is velocity? Displacement upon time. Velocity is? Have you come across this? It will be taught to you in chapter 3. Okay. Now displacement is also length. Okay. So this unit also will be. But what is displacement? It is distance covered in a specific direction. In case of speed, there is no direction, no specific direction. But in case of velocity, you have to also tell in what direction the object is moving. So displacement is a distance in a given direction. But this also unit wise it is meter per second. Okay. Now next you have acceleration. I am giving you these quantities because in the forthcoming chapters you will study about it. So you'll have some basic idea about what are these quantities. So acceleration formula is velocity upon time. It is the rate at which the velocity is increasing or decreasing. Okay. So we say accelerating when the speed or velocity is increasing. So this is velocity upon time. Now we know unit of velocity is meter per second and time is second. So this is meter per second upon second. So what is it? Meter per second square. So this is acceleration. Then you have force. Force is given as mass into acceleration. Everywhere you see that it is combination of fundamental units. Now what is unit of mass? Kilogram. What is unit of acceleration? Meter per second square. Right? Meter per second square. This is called Newton. kg meter per second square is also called Newton or Newton. So symbol of Newton is N. That is N. Newton is name of a scientist. So kg meter per second squared itself is called Newton. Clear? So that is force. चलो एक और करते हैं. Density. How do we define density? Mass per unit volume. So this is mass upon volume. So mass is kg and volume is meter cube. So it's kg per meter cube or kg per meter cube like this. Okay. So I hope you got fair amount of idea about what are fundamental quantities, what are fundamental units, what are derived quantities, and what are derived units.
Yes, sir.
Okay. But it's not necessary that all lengths will be a meter and more than a meter. There are small lengths. Like if you go into micro domain, atomic domain, the lengths will reduce. So now how do we present bigger and smaller measurements? These are standard units, right? But not necessarily everybody will fit into that unit. Some lengths will be a lot less than that. Some lengths are going to be a lot larger than that. Like for kilogram, we also have 100 kg, which we call quintal. 100 kg is quintal. If you have 1000 kg, it is a ton. So when you are loading a truck, it is more convenient not to say 1 lakh kg, but it is more convenient to express the measurement in terms of ton. Okay, so it is convenience of expression. So let us see how to present large and small measurements. So we'll start with the units of length. So smaller units of length. So what are smaller units of length? Meter. You compare all the length with meter. So first you compare 1 centimeter. How much is a centimeter? 1/100 of a meter. So you express as power of 10. Okay. So 1 centimeter. So this is now the prefix to a meter. We use prefixes. Meter is standard unit. Now use prefix centi. And what is its numerical equivalent? 10 to the power -2. 100 part of a meter. So another prefix is, so let's write full form. Centimeter. Okay. Likewise, you have 1 millimeter. This is the symbol. And how much is this? -3 meter. You have even smaller length. So it is 1,000th part of a meter. Then you have 1 micrometer. So it is written as mu. This is a Greek letter mu. M-E-W. Mu or M-U. So micrometer. This is which part of the meter? 1 million, 10 lakh. एक मीटर को 10 lakh parts करो, one part. That is, so this is very small, right? So then smaller than this you have 1 angstrom. This is written as 1 angstrom. This is equal to minus 10 meter. This is the atomic size. The size of hydrogen atom is about an angstrom. Okay, this is the atomic size. So atoms are this small. Then you have 1 picometer. This is prefix and this is minus 12 meter. Okay. If you make 100 parts of a hydrogen atom, 1 part. That's 100th of angstrom. Then you also have 1 FM, femtometer, which is 10 raised to minus 15 meter. So this is the atomic size, this is the nuclear size. Nucleus is this small. 1 lakh part of the atom. Okay? So nucleus is so small. So all of these lengths we're going to study. Then in the next class we'll discuss about large length like kilometer, right? Astronomical unit, light years, parsec. Okay? So you have very large. Likewise, we'll discuss large and small masses and large and small time. Only length, mass, and time. No other units. Okay? So that we'll discuss in the next class. Thank you.
Yeah.